Okay, another example of a monohybrid cross is a test cross. So what is a test cross? Let's look at a specific example. In sheep, wool color is controlled by one gene, whereby white is dominant, black is recessive. If we want to write out our key, we have wool color, and we have, say, big W, which is white, and we'll put a little w, make it different, put a little tail or something on there. That's recessive. So this is dominant, this is recessive. If you're raising sheep, white wool is desirable because when you shear your sheep, you can color it blue or red or purple, right? If you shear a sheep that has black wool, it's very hard to dye that wool any other color than black. So farmers want to have all of their baby sheep every year come out white. Okay, so if we have a white male, a ram, and a lot of times you'll see this symbol to signify males, this symbol to signify females in a genetic cross. We want to know if this white ram is big W, or big W, little w. That is the question, right? Because we know if he is big W, then every one of his babies will get a big W allele from him, making it a white baby, no matter what color the mom is. Okay? And usually you have one male and several females because you only need one male to service several females, and you need the females each to have their own baby, okay, to grow your herd. So mom, in this case, she is going to be definitely little w, little w. We know her genotype because she's black. The only way to be black is to have the recessive allele black. The only way for the recessive allele black not to be masked is to have it in the homozygous genotype. So they have to be the same. Okay, so when we want to figure out an unknown dominant phenotype, the unknown dominant, I guess it's the genotype, the unknown dominant genotype. We want to figure that out. We're going to use a test cross. Okay, and so a test cross always crosses the unknown, which is the dad in this case, with a homozygous, so the same recessive individual. That is the test. We cross it with a homozygous recessive individual, and then we're going to look at what babies come out. Okay, so in this case, we're going to need two Punnett squares because we're going to test this and we're going to test this and see what the offspring would look like. So we're going to go make our Punnett square noise so our Punnett square looks nice, and we'll do another one here. Okay. So we're going to put one parent gametes on the side of the Punnett square. So let's choose this dad to go here. Big W. And then who are we crossing him with? The homozygous recessive mum. Little w. Okay? And then we can put, if dad had this genotype, let's put it here and see what happens. So big W, little w. And we cross that with the test cross, the homozygous recessive mum in this case. So what we're going to get out of here is, you can see, big W from dad donated to each kid. And because mom can only donate the recessive black allele, then we would get 100% In this case, white babies, white offspring. Okay, so we're only interested in the phenotype because we're going to know the genotypes by doing this cross. We're going to figure out that if 100% of the babies, every time we cross dad with any kind of mom, come out white, he's likely to be homozygous dominant. If we see, on the other hand, dad's going to donate either a big W or a little w, mom can only donate little w's, so we're just completing the cross here. And in this case, we're going to get 50% split. We're going to get 50% white, because here's dad's big W, and 50% black, because dad is donating also a little w, and so therefore that black allele with mom's black allele is homozygous recessive, and the black condition can show up. Okay, so if we breed dad with a bunch of sheep, and half the time, a bunch of black sheep, and half the time we're getting black babies out of that, then we know dad is heterozygous. Probably not going to keep that guy around. You're going to try to find a purebred white sheep to keep your herd growing and keep them white so that you can dye that wool any color. Okay, that's a test cross. Cross the unknown, which is dad in this case, with the homozygous recessive individual. Okay, this applies to any time we want to do a test cross. You're going to be given some kind of an unknown genotype for one of the parents, and you're just simply going to cross that with the most homozygous recessive form of whatever gene you're dealing with for the other parent. And then if it gives you offspring and it says it's a 50-50 ratio, you'd be like, nah, dad is heterozygous, depending on who you're crossing. And if it's hey, it's 100% offspring of one color, then likely that unknown parent is homozygous. Okay, just a monohybrid cross, one gene, specifically a test cross, so we know that one of the parents, we know their genotype is going to be that recessive individual. Very common question on a diploma exam.